Okay, exercise 14. Go ahead and break this one down. At 1000 degrees, ammonia gas, NH3, reacts with oxygen gas to form gaseous nitric oxide, NO, and water vapor. Our first step here is to take these names and formulas and put them together as a chemical equation. So we start this off with our two reactants. Ammonia, NH3 gas, reacts to oxygen, which we recall is O2 gas. It forms nitric oxide, NO gas, as well as water vapor, H2O gas. Now we're going to follow the same process as last time. What we're going to do is we're going to count up how many of each element we have underneath the compound. Nitrogen, hydrogen, 1, 3. Oxygen, 2. On the product side, nitrogen, 1, oxygen, 1. Hydrogen, 2, and oxygen, 1. Now, just like last time, we're going to bump into this situation where we have more than one oxygen on the same side. So to help us keep track of that, I'm going to go ahead and write in an oxygen total. Currently, that total is at 2. So as I take a look at this, we're going to just compare things. We have 1 nitrogen, 3 hydrogens to 2 hydrogens, 2 oxygen, 2 oxygen. So we can see right here that our problem is our hydrogen. Since we have 3 in one of the compounds and 2 in the other, what we're going to have to think of is the least common multiple. Well, the lowest common multiple of 2 and 3 is going to be a 6. My target is to get to a 6. So what I'll do is I'm going to do 2 ammonia, and I'll update my totals of those 2 atoms. 2 times the 1 nitrogen is 2. 2 times 3 hydrogen is the 6 that I'm after. On the right side, I have to adjust the water. When we look at it, we see that the goal is 6. So we're going to multiply 3 times 2 to get to that 6. But we can't forget oxygen. 3 times 1 gives us 3. And now I'm going to update the total. When I look at it, I have my 1, 3. Now I have 4 oxygen. Well, looking at it, my nitrogen's off now. My oxygen is still off, but the hydrogen's good. Well, since oxygen is the element, we're going to save that one. We'll deal with it last. The next thing that we'll do is we'll go ahead and jump here into the nitrogen. Since there are 2 nitrogens here on the left and only 1 on the right, the lowest common multiple there is 2. I can multiply 2 multiplied by my nitric oxide, update the totals to get a 2 and a 2. Now for the complete oxygens, it's going to be 2 and 3 gives me a 5. Now that I'm here, nitrogen's good, hydrogen's good, oxygen still isn't balanced. And we're going to notice something kind of peculiar. This oxygen, since it has a 2 here and my total on the other side is a 5, I don't have a way to make this 2 into a 5. If I tried, let's say I multiply it by 5 halves, right? I mean, that could work theoretically, but when I'm balancing these equations, I need whole number coefficients. So 5 halves doesn't work. Well, we've talked about the strategy that we can employ here. You take the complicated thing and you double it. And in fact, now that I've balanced everything else out, well, I don't want to restart all that hard work. What I'm going to do is go ahead and double everything. So I go in here and instead of being a 2, 4 ammonia. Instead of being 2, 4 nitric oxide. And instead of being 3, we'll make it 6 waters. Take a look at everything and let's update the totals and see what that did for us. Now, 4 nitrogens. I have 4 times 3 gives 12 on the hydrogen side. Here on the right, 4 times the 1 nitrogen is now 4. 4 times the 1 oxygen is 4. 6 times 2 hydrogen gives me 12, and 6 times 1 gives me 6 oxygen. When I update the total, well, the total has also doubled. 4 and 6 makes 10, and now I have an easy multiple. The lowest common multiple of 2 and 10 is 10, so I can use a factor of 5. multiply that in, and now I have it. It's balanced.